In just 20 years, it had grown into one of the world's largest truck-operated open-pit copper mines, the Berkeley Pit. By the time it closed in 1982, 1 billion tons of material had been extracted, containing enormous quantities of copper ore, along with gold, silver, and other metals. After all the haul trucks, the men, and equipment were gone, the underground pumps were turned off, leaving this great void to fill with water. Water that drained into the pit from the mine tailings above, and from 10,000 miles of shafts and tunnels beneath the richest hill on Earth. That was 40 years ago, when the Berkeley Pit began filling with acid mine water containing dissolved metals. Over the years, the water continued to rise, to a point where it threatened to contaminate Butte's alluvium by the year 2023.
If everybody had to redo it over, I'm sure there's a lot of people would have rethought turning off those pumps.
This particular treatment plant is a state-of-the-art treatment plant. It probably is the most advanced high-density sludge plant now in the world.
This is a 1983 photograph looking due west of the Berkeley, on the Berkeley Pit rim. There's the M in the background right there. And that's how far we've come right there. That was the water level as of December of 2012. And right there is the critical water level. Right there.
The year 2023 is 10 years away, and at that point in time when it reaches that, which it will, why wait?
Because we got to figure out how do we treat it to meet surface water standards. If we need to upgrade the Horseshoe Bend treatment plant or build a whole new facility, those are the questions we're asking ourselves right now. And then when it's time, we want to be prepared to pump and treat the water, before it's ever discharged to Silverbow Creek. Some of the questions right now we're asking, are we going to pump it straight from the pit? Are we going to pump it from a mine shaft in the East Camp system? We don't know that. What's the best way to do that?
This is going to be the new Berkeley Pit polishing discharge plant. Polishing is just taking water that is already been treated at some form and kind of finishing it off, getting it ready for the final discharge. It will meet water quality, state of Montana water quality standards. For discharge into Silverbow Creek. It will be non-toxic to the environment, to fish and microbes in the stream. The media filters are the big vessels that we're picking up today and setting inside the building. They're 30 feet long, roughly 30,000 pounds. The weight of the vessels is one thing, but we also have to lift them up through the roof before we put the roof on and then set them inside. The plant is designed for up to 10 million gallons coming in the door, and then as we treat it, there will be some sediment, backwash, reject that gets kicked back to the Berkeley Pit or the mine site, and then the remaining effluent or product will be discharged to Silverbow Creek. And it's designed to run 24/7, 365 days a year. With the addition of this polishing plant, we will be able to do two things. We'll basically be able to, one, bring the site water balance into balance, and two, we'll be able to begin pumping out of the Berkeley Pit, where previously we could not do that because that would have added additional water to the circuit that we couldn't handle. But now with this facility and the ability to discharge to Silverbow Creek, we can start pumping out of the Berkeley Pit, and we can manage the site, the water balance the water on site, and maintain the Berkeley Pit at a steady elevation. Basically stop the rise of the Berkeley Pit is our goal.
From the beginning, the quest has been to stop the rise of the Berkeley Pit water. This is part of the answer. Begun in 2018, this plant was designed to polish the water from the Berkeley Pit complex. That is, clean the water to a standard that could be safely discharged downstream.
My name is Bob Kimball. I'm a vice president with Wood, and I am the project manager for the polishing plant here. I'm a chemical engineer by training, specializing in industrial water treatment, and this will be the 10th design build project I've worked on over the past 30 years. Probably one of the unique things about this project compared to some of the others that I've worked on, this is a very large project, large flows. We got big equipment, we got big pipelines, and so we've spent a lot of time making sure that all the hydraulics are correct and that we don't have water hammer issues and those kinds of things. You know, and this is, as being a design build project, it's a fast-paced project. It was awarded last June 1st, so we're a little over a year into the project, and we're actually ready to start up this week. There's two main treatment technologies associated with this plant. There's a fine particle filtration system, which is basically a multimedia filter. And we have a reverse osmosis system. And reverse osmosis technology is the same technology that's used to convert ocean water into drinking water. So it removes dissolved salts from the water. The system is completely automated. We have a lot of controls in place to prevent discharging off-spec water, and the system has a lot of flexibility to operate in a number of different configurations in anticipation that the water chemistry may change over time. And so we've got a number of different operating modes to adjust for changing conditions.
There's been some concerns in the community about gypsum and kind of the armoring of Silverbow Creek when it's time to discharge this treated water.
One of the things that we're working on is ensuring that when we discharge this water, we're not going to scale anything in the creek. So that's an important factor to this operation, is to make sure that we can anticipate and prevent any adverse effects in the creek. And in fact, in some cases, we should be able to improve the water quality in the creek. So we have a total of 6 pressure vessels. Each pressure vessel has 3 filtration cells. Each filter is capable of treating up to 3 million gallons per day. So the multimedia filters consists of basically we have a gravel layer at the bottom to support the media, but the two medias that do the majority of the work are just a fine silica sand and anthracite. Those are 2 common medias that are used in these types of filters. The anthracite actually increases the holding capacity of the filters, and by having 18 inches of both medias, we get really good filtration through this type of process. Because the system is gravity flow from top to bottom, we don't have to pump the water anywhere in the process. The only motors that we have in the system are the blowers that are used once a day to backwash the filters. When we're running the RO system, that's a different story. We do have fairly high operating pressures that are required to remove the dissolved salts, but we're using low pressure membranes. We're using the very lowest pressure RO membranes that are available on the market. So compared to other RO systems, we're actually running at a very low energy consumption.
We've laid about six miles of new pipe on the property and 3 new pump stations here. One of these pump stations is down here at the Berkeley Pit. It's pumping water.
Berkeley Pit water makes a long, circuitous route before it ever makes it to the new polishing plant. This spaghetti diagram shows the maze of water piping at the Montana Resources mining site. Water is first pumped out of the pit at the rate of 3 to 5 million gallons per day, up to the precipitation plant, where copper is extracted from the water. It is then sent through the Horseshoe Bend water treatment plant, where lime is added to the water to raise its pH. That causes remaining metals to drop out of solution. The treated water is then incorporated into the mine's milling operations. From there, lime is added to the water, creating a tailings slurry that is pumped up to the Yankee Doodle tailings impoundment. In addition, acidic water that seeps through this mountain of mine tailings, called the Horseshoe Bend seep, collects at the bottom, and another 4.5 to 5 million gallons a day is also pumped up to the tailings impoundment, where the presence of lime raises the acidic water's pH. At the head end of this large lake is open or free water that now has a higher pH of around 11 and contains few metals in solution. This water is pumped out of the impoundment and sent by gravity all the way down a 2-foot diameter pipe to the new polishing facility.
My name is Ron Halsey. I'm the operations manager with the Atlantic Richfield Company, and today we've been walking through our polishing plant, which is part of a larger pilot project that we've been working on. It's kind of the last step before we discharge water to the creek. The water chemistry to change. Our pilot project really has 3 main objectives. First is we want to verify that we can hold the water level in Berkeley Pit steady. Second is we want to get some water off site. There's a lot of water stored between the Berkeley Pit and the Yankee Doodle tailing lake. Third, we want to test different filtration methods to verify that we can safely discharge water to the creek.
This is water coming from the Yankee Doodle tailing impoundment. First off, as it comes through here, is this pressure gauge. And what this does is reduces the pressure of the water coming down the hill. It's coming in at about 70 psi, and it's going out about...
As water comes into the plant, the pH is already at about 10 or 10.5.
We want to keep enough pressure that we run this entire system through gravity.
And the first step in that process is to reduce the pressure to 55 pounds. Then we add a little bit of chemicals to the system to coagulate the particles, and then that water flows through the filters. The particles are entrapped in the filter media. The filtered effluent then is pH adjusted with carbon dioxide to about 7, and then we go to the product tank and it's discharged. In some cases, if we want to remove dissolved salts, we'll run a split stream of that filtered effluent through a reverse osmosis system, and then that treated permeate from the reverse osmosis system is combined with the balance of the filtrate, and that is discharged to the creek. The way this system works, we have the ability to automatically go off spec. If, for example, our pH is not in range in our product tank, we will actually switch some valves so that we automatically take our filtered effluent back to the mine. If the mine can use that water in their process, they will. If it's more water than what they can handle, then it'll actually overflow into the pit. So there is a potential for some of this water to get back to the pit. The RO reject, when we're running the RO system, also goes to the pit. Because it's a fast-paced project, we got our designers working side by side with our constructors throughout the project, and there's been excellent collaboration by the design team, the construction team, and with our client, Atlantic Richfield, Pioneer, Copper Environmental. Everybody's come together and I think made this project a success so far.
off the cover of the valve?
No, it's just plumbing.
Right. Okay. So now I closed it. Higher differential pressure up top.
It's going all the way to 80.
Yeah, once we bleed that out.
Are we okay open and close?
We can... I'll just open this up normal.
Yep, let's see what happens.
After days of test runs, it was finally time to open the valve of the new polishing plant and send the cleaned water by gravity down the 2-foot diameter pipe to Silverbow Creek.
Open that inlet valve all the way up.
Actually, go ahead and open it down. Yep, we're ready. Dropped all the way to 0.
So how much do you want to put back in?
It would be a long 20-minute wait before that water traveled the 2 miles to the discharge point. Then, at 10:40 a.m. on September 30th, 2019, the polished water bubbled up in Silverbow Creek, just above the confluence of Silverbow and Blacktail Creeks.
This is 4,000 gallons a minute, which is roughly 6 million gallons a day, which is roughly 9 cubic feet per second we just added to the creek. So.
It is an important start in the effort to eventually tame the Berkeley Pit. A little more than a year after it was started, the completed plant is successfully polishing up to 10 million gallons of water per day.
This is a big day for us in Butte and the Berkeley Pit, so yeah, it feels really good. Kind of a feeling of accomplishment. Maybe we should just call it a day and go home early.
The construction did take us a little bit longer than we had anticipated. We had hoped to be running earlier, but it was really more important to get it right than get it fast. And so we really focused on making sure we did it safely, and the system works, and now today we got discharged, so we're pretty excited about that.
By early 2020, the new polishing plant was treating up to 10 million gallons per day. Water in the Berkeley Pit had finally stopped rising.
Since we started pumping out of the Berkeley Pit, we have basically held the Berkeley Pit within plus or minus inches, an inch or two of where it was last year.
Workers raised the support structure, and transport trucks arrived later in 2020 with 4 new reverse osmosis skids that would triple the reverse osmosis capacity of the polishing plant. The plant was originally designed to accommodate this expansion in case of future changes in water chemistry at the site. Each of the reverse osmosis skids contains long tubes into which the filtering membranes are inserted. Unlike the filtering vessels that operate mostly by gravity, it takes a lot of pressure to run reverse osmosis. The skids are powered by 200 horsepower electric pumps. The pumps can run 24/7. If the plant should ever lose power suddenly, a diesel generator outside will allow operations to shut down safely. The Environmental Protection Agency approved the plant's expanded reverse osmosis operation in early 2021. Now, water that is pumped out of the pit to the Yankee Doodle tailings impoundment flows by gravity down to the polishing plant, where its pH is lowered to 7, and it is filtered through layers of anthracite, sand, and gravel in the cells of the filtering vessels. That water is mixed with water filtered by reverse osmosis and discharged. The mixture is water that is safe for aquatic life in Silverbow Creek and all of the rivers downstream.
Our goal was stabilize the Berkeley Pit, keep it from filling up anymore, test treatment technologies, which we've done with the polishing plant. We've tested the filtration technologies, and we're now installing reverse osmosis technologies, and we'll begin testing those probably over the course of the next year. And our third goal was to kind of do a water reduction effort from the mine site, which is get some of the water that was on site, treat it in off site, and we've been successful in doing that. We still have a ways to go, but we're continuing to treat and discharge. We anticipate for another 3 to 4 years under the pilot project.
The Berkeley Pit, now at long last, has an outlet, and the pilot project polishing facility will continue to be improved and adapted as the needs of the site change.